Okay, everyone. Doing this as a makeup for the class we're missing today. I mean tomorrow, Monday, October 28th. First of all, I want to remind you that we have less than a month left for the end of semester. The Create Symposium is on the 21st of November. It's between 2 and 3 p.m. so you better make sure you can make it there to get permission from your jobs and stuff. Now, Create is not mandatory, so for some of the projects maybe it's not even the best place to present, so you better make sure that you're testing your projects wherever you can, and you should do it before that time. So this is basically your last warning that you should wrap up your projects and start testing and putting them out where people can use it, whoever your audience is, okay? Now the main thing I want to talk about is the HackerRank project, the question I gave you last week, because very few people were able to do it. And there were two questions. Well, actually there are three questions. So there were two questions inside the challenge I created, and I also gave you a link to another question. For some reason that question was, I could not add it to the challenge, but it's a good question, so I gave you that separately. And out of these, only two of them are mandatory. So if you finish those questions, you get full points. And there's a second question in the challenge I added, which is like a difficult question. But I don't know if you guys found it, the mandatory questions difficult, because I only got very few submissions. So I want to quickly look at these. 1 second, I want to check something. Okay, let's start with from the challenge. So if you click on the challenge, it's gonna look like something like this. Let's see in here. So there are two questions, and this is a mandatory question I wanted to do. Let's click on that one. And the question's about hashes. So we mentioned earlier, I mean, several of you already knew about this. Farzan always talks about using the hash set, and it also comes in the interview question, so there was a request to do this. So I did it, but very few of you submitted, so I'm not sure what's happening. If you either don't understand the concept or you didn't have time to do this, so you better let me know what's happening. But just to review, what is a hash table or what is a hash set and why is it important? So I gave you a link, a video from HackerRank. So a brief HackerRank video. So this video actually talks about, it's a 6-minute video that talks about hash tables and hash sets and why are they important. So you need to watch that video, because I'm going to build on top of that. In that video they show you like how is a hash tables built, and you can build your own hash table. It's not a very difficult task. It's basically an array. So let's go back to review what we talked about the different performance of different operations, right? So if I have an array and I do an array lookup, so I have an array and I have, okay, something is not happening. Oh yeah, it's just going to the next page, sorry. Alright, so when you have an array and you can address any item in an array, then getting this is basically takes big O. Like to find an element in an array is just O1. That's because you can, if you know where the element is, it's easy to find it. Now if you're searching in the array, you have to go search one by one. How much time does that take? That will take O to the n, because we have to go through each element in the array, right? Now, as opposed to that, if you remember, we were doing a binary tree or binary search, where you are dividing dividing the search space into two at each step, and that was giving you a logarithmic solution, so it was log n. Okay, so that was saving you some time, or exponential time. Now, so O(n) is the worst, log n is less, and if we knew where the things were, it could have been O1, right? However, so let's see. So it could have been O1. So is there a way to make it to know where it is? So that's the question. Like, if you knew where the thing was, then it's very easy to find it, and that's what the hash tables do. So hashing is basically finding the index, finding I. Okay, so that I is the I on here, and that will give us an O1 solution. If you've seen the video, it's basically talking about the other video from HackerRank. It talks about how you can calculate the hash value that will point to an index in the array. So like if you give it a string, so you have different strings that you want to put in the hash table, and you can find a way to calculate an index from those strings. So basically you can do some mathematical calculation such that like the first string goes to the first bucket, second string goes to the second bucket. So bucket is just like a position in the array. So every time you look up that string, it always points to the first bucket. And the way that's done is that you basically calculate an index. And the simplest way to do that, you can take a string and take each letter and then look at this ASCII code and then like add those numbers or multiply them with something. So basically you can make sure that any input can translate into a number. And that number could be a very large number, but there are ways to make that smaller. So basically you can do a modulus operation and bring it down to a range that you want, and then you can put them in an array. Let's go to the next page actually, so I can maybe explain that in here. So we don't move this one. Okay, good. So for example, you have a string test, and you want to put this in a hash. Basically you can get like, you can add the t plus e plus s plus t, and you calculate the number, like it will be like a number 162, for example. Now you don't want to like put in the 162 location in the array, so basically you can take that 162 and do a modulus operation with like, maybe you have only 5 elements in the array. So 5 modulus 162 modulus 5 will be what? It will be a 2, because 160 is divisible by 5, so 162 is not. So the last 2 will be the modulus operation. So in the array, we can go to the second location and put that, whatever you're putting, we can put the object that contains the value that we want. Now, what is the point of all of this? The point is that we can calculate an array location. So we initially started with the string, and then we did some kind of transformation to the string. We like took each value of these letters and added them together, and we got this number, and that number gave us this array. Now the thing is that every time in the future, like you get the same string, and you add the letters in there, you're always going to get the same array value. So that's the whole thing about the hash, is that you can find a transformation, and it will be a deterministic transformation, which means that every time you have the same word, it always maps to the same location. That means you can always find the word without searching. So that's the whole point. And then this way you get an O1 solution, O1 search. Okay, so that's how the hashes work. Okay, so going back to the question, we can discuss about these on Wednesday, and you can also like write some responses to my post in here. But we'll discuss more in class on Wednesday before the presentation. The question that we were looking at, so now how can we use this hash operation? So hash operations, if you listen to the previous video carefully, the hash operations are very popular, and you should always think of using a hash table or a hash set for any problem that you receive, because it's a very efficient solution, right? It's instead of like searching or sorting, you can put things and find things in constant time, almost instantly. So in this question, what's happening? They are talking about finding unique pairs, right? So there's like John and Tom, John and Mary, John and Tom, Mariana. And what they want from you is that to check at each step. So like the number 5 is like how many inputs they're giving, and at each step you're supposed to tell how many unique things you've seen so far. So initially, like, you have John, Tom, so that's the first one, so that's the first one, so it's the unique one. And John, Mary now is unique, it's different than the previous one because you're looking at the pair to be different. Now that's a bit confusing because like so far we talked about only one thing that we put in the hash. So how do you put a pair in a hash? So that's the question. And then on the third input there is John, Tom again, and John, Tom has occurred before, so that's not unique. So far we only have 2. So you had 1, 2, and the third input is not adding any unique input, so it's still 2. And the fourth and fifth are also the same, but they're new, so they will increase the unique inputs to 3. And they explain it down here. Now, I still want you to solve this problem yourself, so I'm not going to tell you exactly how to do it. But basically what you want to do, like you're trying to find the unique elements, so you can, if you put them in a hash set, and the difference between a hash set and a hash table is that in the hash set you don't have a value, you only have the elements. And this is the perfect question for a hash set, because you just want to put this element in a hash set and then check if it's there or not. If it's not there, then it's a unique input. If it's already there, then it's not unique, we don't have to count it anymore. Okay, so that's basically how we need to solve this. And how do you deal with a pair? Because in a hash set you need to put a one thing, right? And if you go back to my example, like, okay, so like you can, from one object or a string, you can create a hash code, right? And then which will translate into an array position. Now, if you had 2 words, how would you do that? Well, maybe the simplest trick, you can just combine those 2 words into a single word and then use that as the hash code. So that will be a very simple solution. Okay, that's my hint to you. Alright, so I'm not going to tell you more about this question so you can solve it yourself. And I'm going to switch to the next question. It was the ransom note. So if you're looking to commit a crime and you want to write a ransom note, I hope you're not, but this is just a philosophical question here, and you basically, it's a similar question. It's again like, I think can be solved with a hash set, because the only thing they are asking you to do is like look at the magazine, and the magazine contains some words, and you want to like write your ransom note by using the words in the magazine. So they give you like 2 things. So first they give you a line with the magazine, and the second line they give you the hash, the note that you want to write. And then you're supposed to check if all of the words that you need is available in the magazine. Okay. Now here's the trick. Since you're cutting the magazine and you're taking the words, when you use the word one time, it's gone. So if you look at the second example, 2 times 3 is not 4. This is the magazine, right? So all these words are available. And what you want to write is 2 times 2 is 4. Now all of the words are available in the magazine, but the answer is no. The answer is not. So it's not possible to write this with the magazine. Why? That's because the 2 is used twice, but you only have 1 copy. Okay? So basically, you need not only you have to keep track of the words in the magazine, but you can only use them once. Okay? So the 2 questions are similar. Like in the previous question, you're supposed to keep track of unique inputs in a hash set, and in here you have to find all the unique inputs. Actually, I'm wrong. I think this one requires a hash table, because you may have 2 copies of the same thing and you want to keep the count. So in this hash table you want to have a unique input, and it should be associated with the value, which should be the count, so you know how many you have left. So you want to keep track of what's available in the magazine, so that when you're writing your note you can check if they're available and if there's more than 0 available, and once you use it you have to deduct it or remove it from the hash table. Okay. I don't know if I need to tell you anything more about this, but both of these questions are mandatory. If you're looking for a challenge, I have one more question in here, which is a more practical use of the hash table, and they're asking you to find parse domain names and find the words in them. And there are some complicated versions, like a single word here named cheap. You have to like extract the name and cheap separately. And for this they offer you a dictionary of 5,000 most common words, and again, like, you'll have to like use the dictionary to look up things, and if you were searching every time, that would have been taking forever. So that's why using a hash table is going to be a much faster solution. And there's a lot of explanation in here, so you should read them if you want to do this. This is going to give you a huge bonus, because the questions already like more points than the other questions. So because the 2 mandatory questions I gave you, I gave them 5 points. Usually I give 3 points for these coding exercises. Alright, I think that's it for now. I hope to see you Wednesday. Write me some comments as a response to this post I'm making. And I entered some grades and gave you some feedback on the resumes. I'm not done with the second part, so I'll give grades for that too. And I'll see you guys on Wednesday. Oh, by the way, if you haven't gone to any hackathons, I was at the Hack GT, the Georgia Tech hackathon, over the weekend. It was quite a crazy event, and I know that they didn't take many of you, even though you applied, some people, but they usually like give preference to freshmen, and of course the Georgia Tech students first, the freshmen, and then maybe like people coming from far away, so they have a lot of requirements. But if you look at the Discord, we're posting like the last few hackathons that are happening in this season. There's like 1 or 2 left only. There's Hack GSU next weekend, and there's also, I think, Vanderbilt, which there's a free transportation to it. So maybe like you can do this last chance hackathon trip. Alright, I'll see you guys on Wednesday.